I'm glad to be here with my friends from the Trino Gateway community. So we are going to open up the Trino Gateway today and we'll provide a Trino Gateway project update as of December 2024, which is still the case today. So I have a couple of the Trino Gateway sub-project maintainers with me. So I'm glad to introduce to you to Jaehoo Yoo, who's a regular sub-project maintainer and great contributor. Myself, I'm Manfred Moser. I help with the project as well where I can. Try to lead our dev syncs and all sorts of other stuff. Starpoon can't join us at the moment. He's also a very active contributor. Vishal is right here, and Will Morrison are also here. So we are trying to get the Trino maintainer sub-project maintainers process going, and we have lots of pull requests, lots of innovation happening. I'm glad to have you here with me, Will, Vishal, and Jaehoo today. What are we going to do today? We'll talk about what Trino Gateway is, and Trino Gateway solves a problem that's a reality that you've seen from many presentations already, and that is that many people run many clusters, and that's just something that's necessary with Trino, and not just necessary, but also has lots of benefits, but it also creates pain for users. Each cluster has a separate different URL, and that means separate configuration and other aspects. So Trino Gateway can sit in front of those many clusters, providing one user interface, and it's a load balancer, proxy server, and a configurable routing gateway for multiple Trino clusters. So it enables many cool features that people need, like HA and others. We'll dive into that in more detail shortly. But first, I want to maybe hand over to Will to give a quick project overview, if that's all right.
Yep, as long as I've got my mic on, and it looks like I do. All right, thank you, Manfred. And yeah, happy to be giving another update here on the Trino Gateway. So for folks that have been following this project for a little while, it was originally called the Presto Gateway, and it was open sourced originally by Lyft. The project was still very popular at that time, but the community had a tendency to go in different directions. It kind of spread out. Bloomberg, where Vishal is from here, ended up contributing their fork back, and we onboarded it into the Trino project back a little over a year ago. We presented at last year's Trino Summit in 2023. If you're interested in participating in this community, we're very active. We've got a dev sync. All are welcome. You don't need to be a sub-project maintainer to be on that. Just hit us up on Slack on the Trino Gateway dev channel, and you can find more details there. We're up to over 500 commits and 13 releases, and we try and get one out every 2 to 3 weeks. There's a lot of users out there, including all the folks that you see out here. A lot of these folks I'm working with directly. A lot of them are participating in the project actively as well. We've got folks from retail like Best Secret. We've got media like Bloomberg. We've got travel like Expedia, Line, Yahoo, Naver, where Jaehoo is from, Slack, and many more, including some big folks who can't quite admit to it publicly. So if you want to get started with this, as Manfred was saying, this is a very common things for folks to run into when you're using Trino. We've got separation of compute and storage, and it's great, but there are certain things that you might want to do if you want to do an online configuration change or upgrade, where say a blue-green style deployment, where you end up finding, boy, it'd be really nice to have 2 clusters right now and be able to hide that from my actual end user clients, right? So if you want to get started and play with this, you can deploy it via a jar file. We have a Helm chart that's actually living in the Trino DB charts repo now. You can do Helm repo add and Helm install and get up and run with that pretty quickly. You can deploy this. The Trino Gateway is a stateless server. It maintains state in a database. So you can run a whole fleet of these things for high availability behind a load balancer. The configuration, I will point out, is a little bit different than Trino's configuration. We use YAML, which actually works very well with the Helm chart because you can define arbitrary configuration in the same language that we use in Helm. So for those of you that were following along from our last Trino Summit presentation, where we gave a number of goals that we were trying to hit, one of the big things was that since this project had been originally developed by Lyft on the Drop Wizard framework, we've fully migrated over to Airlift. So we're sharing a significant part of the code base with Trino that we weren't sharing before. We've aligned a lot of our code styles and patterns, leveraged the test suites and functionalities within Airlift. So if you're coming over as a Trino developer, things will look a lot more familiar to you now than they may have looked a year ago. I really want to give Star a shout out for that work. He drove a significant portion of that Airlift migration, which has been incredibly helpful. We've also got a few things to do. We've implemented open metrics for observability. We're still working on open telemetry. I'll say we have containerized this, which makes the deployment a lot easier, as you guys know. We've expanded some capabilities. We're able to use external services to provide routing information. I believe Jaehoo is going to talk a little bit about that as well. So major new features that we're looking that we have added are the Docker container and Helm chart. We're working on dependency updates and making sure we don't have any major security vulnerabilities. We're keeping in line with Trino and updating to Java 23. We've got a brand new UI, which was donated by the community. It looks great. And we also have improvements in the internal security within the gateway. Yeah, so additional enhancements, more changes that we have since last time. We have more configurable routing modules. We've added logic to do some significant processing of the incoming query and request to extract user headers, extract information from the SQL. We have modules that will do active load balancing now based on the load of backend clusters within a routing group. We fully support OAuth now using cookies to ensure that the OAuth handshake is pinned to a single backend cluster for the duration of the handshake, and that external routing service I just mentioned. Speak a little bit about common use cases here. One of the most common things I mentioned is the need to do an online configuration change or upgrade. And another thing people obviously want is to avoid single points of failure with Trino, where you will have a single point of failure with a coordinator. So simplest use case is high availability, where you have two clusters. You're not applying routing logic in this case. Again, you can do either stochastic routing, where every query randomly goes to a different backend, or you can do active load balancing. This will prevent downtime. If a cluster goes down, you'll have to retry queries, and it should, over the long term, evenly balance load within clusters.
Vishal, are you going to tell us more about your use at Bloomberg of that no downtime upgrades or just the high availability?
Yes, I'll do that. So I think one of the ways you can do that, as we explained here, is this is just the extension of the high availability feature which Trino Gateway offers. And in a big picture, what we do is we group Trino clusters into similarly, featured Trino clusters into different groups. And within each group, we try to route the queries based on the routing logic. So, or load balance within that Trino cluster. So using that, we can do the blue-green deployments, basically with the event distribution or based on the load. So, and based on the load basically means that you can distribute part of your request on one cluster versus the other. So the blue, basically, it means you basically give event distribution with blue and green, and then you deploy something and then shift the workloads as and when you test one side of the groups of the clusters, like blue or green, right? Also, you can use other methods like canary. So if you just want to like try out partial requests to one group and then to the other group, you can do that, and then you move on to the then you upgrade the whole clusters. Sorry, after upgrading the whole clusters, you route the whole all the requests to all the clusters. Meanwhile, yeah. So and that basically is the no downtime upgrade, right? Yeah, please move to the next one. Yeah, so once you have the basic routing figured out, I think the request always becomes, or the use case always becomes, like how can we balance it more evenly or based on the load which each cluster is gonna handle. So sometimes you have queries running, like longer queries are running on one cluster, and maybe that cluster is more busy. Now you basically want to look at the load, and then from the load you are going to figure out what queries to send to the other one. And then we use a very simple logic wherein we say, like, per user basis, what queries are running and how many numbers of queries are running and how many numbers of queries are kind of queued on one cluster, and then we decide which cluster to use. Also, like the stochastic router is just gonna do like the random distribution, and there are like even more smarter routings which are gonna dependent on your particular load and use cases that I think Jaehoo will talk about next.
Thank you, Vishal. My name is Jaehoo from Naver, and I'll continue with the presentation. Before discussing use cases at Naver, I'll give a quick introduction to the company and my team. Established in 1999 as a search engine in South Korea, Naver is known for the #1 search portal within the country, outranking in Google search. I am part of the IDA data platform team, specifically the team Security, where we provide a platform to handle large amount of data in a short period of time. Here are some impactful numbers that might interest you. This year, we serve an average of 58,000 queries daily in production, processing about 800 terabytes of data or physically reading 25 trillion rows. While the number of queries running in our cluster may not be exceptionally high, the amount of data processed is enormous, as we store over 12 petabytes of business data in our data centers within the country. To efficiently manage the massive amount of data and high query volume, we needed an improved solution for handling large datasets within our Trino clusters. And this is where the Trino Gateway comes in.
Yep.
Yeah. Thank you. Since the introduction of Trino Gateway at the last Trino Summit, we recognized the need for dynamically managing routing logics. To address this, we implemented an external routing service. The configuration process is very straightforward. Set the rules types to external and specify a URL path for sending post requests that include query information, headers, and user data. This enhancement offers several benefits. First, it enables dynamic, context-aware routing decisions and allows for easy updates to routing logic without requiring changes to the Trino Gateway. Also, it facilitates seamless integration with the existing systems and data sources. With this external routing service, you can make more flexible and intelligent routing decisions based on various factors and real-time conditions. Next slide, please. So now I'd like to delve into details of the logical routing I mentioned earlier. We've implemented this in an external service to create a more flexible and efficient system. First, we introduced a custom routing manager. This manager is easily configurable by adding modules, enabling complex and dynamic routing decisions, which criteria would include the query statistics, cluster load, and performance metrics, or user privilege, for example, VIP status. This criteria allows us to make more sophisticated routing decisions. Next, we focused on resource optimization. Our system identifies and blocks failure-prone queries. This prevents resource waste on operations that are likely to fail. Lastly, we paid special attention to metadata query handling. We route catalog and table information requests to a dedicated metadata cluster with just one worker. This efficiently manages high-volume requests from IDEs like PyCharm or big I tools like supersets. The key benefits of this approach are reducing the load of main clusters in Hive Metastore and mitigating the impact of users without full table access permissions. Next slide, please. The next up in the agenda is our project's future, specifically focusing on initiatives for developers like us. We plan to enhance the integration of routing modules, making it easier to add and manage them within our framework. Additionally, we aim to optimize our system for scalability and efficiency, ensuring that it can handle increased loads effectively. And finally, we will improve our cluster monitoring capabilities to provide better insights into status changes and system health. Next, let's discuss our project's future from the user's perspective. One of our key initiatives is to improve the getting started information and process, alongside enhancing routing and monitoring tools. This combination will make it easier for new users to onboard while providing better insights and control over the operations within the Trino Gateway service. We also plan to develop a richer user interface that enhances usability and overall experience. And lastly, in the long term, we are looking at adding support for managing Trino clusters. This is a significant task that will greatly benefit users by simplifying cluster management and engagement within the Trino Gateway service. To wrap up our presentation, I would like to leave you with a key takeaway. If you use multiple Trino clusters, you want to look at Trino Gateway. Our project has indeed come a long way, but we're excited to say that there's an even long road ahead. We have big ideas and ambitious plans for the future of Trino Gateway, and for those interested in learning more and getting involved, I encourage you to visit our website at trinodbgithub.io. There, you'll find comprehensive information about the project and its capabilities. And if you're keen to dive into the code and or contribute, our source code is available at the GitHub at github.com/TrinoDB and Trino Gateway. And lastly, we invite you to join our community on Trino Slack. You can find us in the Trino Gateway or the Trino Gateway dev channels, where we discuss developments, share ideas, and support each other. Thank you for your attention, and we will look forward to your participation in the Trino Gateway project.
Awesome. Thank you, Vishal, Jaehoo, and Will. We have quite a bit of time, and so we can take advantage of that and show people a bit more on what's going on in the project. So this is our website, as you can see, and we have some resources here, recordings from old talks and stuff like that. We have a list of our users. If anyone wants to let us know that they are also a user, we'd gladly add them. Our release notes are here, very detailed. And then here is some of the getting started reference and contribution documentation that hopefully can help everyone. In terms of the questions and stuff like that, I think there's a few things we want to chat a bit more about, and that is, where am I? Here. In terms of the high availability, I just wanted to mention, and also the blue-green upgrades. In the last presentation that Will and myself did at a conference, I honestly forgot which one it was, we did a demo, and it's definitely worth watching. When you do this blue-green deployment, it's amazingly simple. You're literally just setting the cluster that you want to drain off any work to inactive in the Trino UI, Trino Gateway UI. So you're just logging in there, pressing inactive, it will drain, and then you can drain to the other one, drain and like only route to the new one. And then you can upgrade and test. And with like your custom routing logic that you can write, you can still access the new upgraded cluster and test it there. So that's definitely super handy and also fun to see and play around and check it out how crazy simple that is. It used to be a complicated task, right, Will?
Oh yeah, I mean, doing this with something like a cloud load balancer is doable, but definitely tricky and failure prone.
Yeah, and also not something you can show anyone because everyone uses a different cloud load balancer and has a different configuration and everything. So it's more difficult. In terms of this system, hang on. Yeah, here. I wanted to talk to you a bit about this Jaehoo. You mentioned that you have a dedicated metadata cluster. I think that's a very interesting approach that we discussed, of course, in the past. So maybe tell us a bit more about how that decision was made to do that, and also maybe talk about how we might want to figure out how we integrate something like that in the Trino Gateway itself, or like as a special configuration.
Well, so we have the Trino resource groups where we limit the number of queries running concurrently. So let's say for 5. So if the user is running like heavy like Trino query that takes more than like 5 or 10 minutes, then and it fills up all the queues of 5 queries, then next if he or she would want to like list the tables which the IDE does, like PyCharm or supersets, they like query like 50 or like 100 at once to get the table metadata, then it will be blocked or will be at the queue status. So to prevent that, we would route all those IDE stuff that requires metadata info to a different cluster, which would not be counted within the Trino routing group.
That's cool. And I guess that also enables you to potentially think about caching some of that metadata because it doesn't change that fast in the future and things like that. So definitely something we noticed also when we were working on integration with the different UIs. Some of them are very aggressive about pulling a lot of initial data down, and it leads to a very bad user experience ultimately, because like a person goes, oh, I'm just going to connect to this Trino cluster to write this little short query, and then it just sits there and churns and churns and loads the data that ultimately the user might not ever need, right? There's like 10 catalogs with like 100 schemas overall in there, and you just want to access one. You don't really care about the metadata for the 99 others, right? So it's a very interesting approach and a good way to do that. I also wanted to mention something that is maybe sometimes not always so well understood, and that is when in this architecture here, when Trino Gateway is running and you have multiple Trino clusters behind it, there's a constant check going on. So the Trino Gateway basically knows how healthy every Trino cluster is all the time. And so we basically can react to failures on those backend clusters. Maybe Will or Vishal, do you want to talk a bit more about that?
Yeah, I'll take that question. So we basically use Trino's existing APIs, like the UI API, and there'll be like a new endpoint which we'll use to check the health of the Trino cluster itself. And that comes handy when, for whatever reason, like, if a Trino cluster is not responding, like it could be a network issue, it could be like just the machine being down. So in that case, like you're not going to route queries to that cluster. Also, I'm basically going back to your blue and green deployments. One of the things which really comes handy as a part of your deployment mechanism, which if you want to automate it, is all the adding and removing and updating of the Trino cluster flow, like logic to route the requests. So bringing something online or offline, any of the clusters, is also available via APIs. So you can just send the curl requests or use that JSON payload to add a Trino cluster's configuration to the gateway. That way you can enable or disable using the API. So you don't have to use the UI in order to enable a flow towards a cluster or away from a cluster. So that comes very handy with that. Will, you want to add anything to that?
I think you pretty much covered it there, Vishal. I was just looking at Deepak's question here in the chat, which I guess I could speak to. The question is, how do you identify pure metadata queries? One of the things we briefly mentioned is that we do some SQL analysis, which I want to be clear to folks. There's definitely it's a double-edged sword, really, when you're doing routing based on the SQL, because as we all know, or maybe we don't all know, so let me clarify this. This is a purely syntactic information. There's no analysis performed of SQL by the Trino Gateway. So we don't know if something that is a fully qualified name is a view or a table. There could be cross-catalog references that we're not aware of if it's a view. We don't know data types. We don't actually know the identity of a catalog. We don't know if data lake is Iceberg or if it's Oracle, so you need to be very careful with this. But if you want to identify a pure metadata query, you can take a look and see, are all the tables referenced from an information schema, or alternatively from system JDBC schema, or you can also look at the query type. We will process the SQL and identify if it's a show or a describe query. So I think I see Jaehoo answered this in the chat as well, but that's one of the capabilities within the Trino Gateway.
Yeah, and all that information can be used for routing logic, right? That's also why we want to add a framework for routing modules, because ultimately the use cases are very, very different, right? Like the minimum super simple usage for Trino Gateway is you have two clusters that are exactly the same. You put Trino Gateway in front of it and you do stochastic routing. So you distribute the load across the two. And if anything goes down, well, only like half your users are losing any running queries and anyone can continue. Like that's HA straight there, right? So that's like the minimum use case. But Trino Gateway supports any clusters behind it. So it's very common to have dedicated clusters, like the example we showed when we did last time. Will showed like the idea that there's an ETL cluster, so a cluster that's optimized for doing workloads. Maybe it's even configured to use fault-tolerant execution on Trino and has more of that stuff going. You could have a cluster like that, and then you want to route to that one differently, and the logic to what to route to that is different as well. Interesting use case also coming up soon is that the new spooling protocol in Trino allows high performance download of data, right? But like maybe not all of your clusters are configured to have the spooling protocol, but you have a workload that relies on getting lots of data locally in some Python tool. So you want to make sure that when you run that tool, you get connected to that cluster that has a spooling protocol enabled. So there's a lot of those kind of use cases that get pretty complicated and also very specific to a specific company's policies and requirements. So having a routing module, and like Jaehoo has implemented the external routing service where they can basically do whatever, is super helpful and flexible. And that's also the power of Trino Gateway, in my opinion. As a project, we're very closely collaborating. Some big companies with very different use cases, and we take them all into account and collaborate, and that's really cool. So I really love that. So it's a successful project, in my opinion. We've come a long way, and we have exciting things ahead. Anything else you want to mention, Vishal, Jaehoo, or Will? Because we have another 2 hot minutes before we have to carry on with more exciting sessions for Trino Summit.
Yeah, all I will say is like you're always gonna start with like simple high availability use case, and then you'll gradually go on load distribution, upgrades, and very, very specialized use cases for your routing and load balancing, and gateway supports and could be enhanced to support all those use cases. Yeah.
Yeah, Neil is also asking an interesting question. He's asking, can Trino Gateway resubmit queries that failed back to the same cluster. So that's one of the things that Trino Gateway does not yet do, because what it does, it forwards to the underlying clusters. It does the routing. It does not kind of pretend to be a Trino cluster, cache and then forward to the clusters and manage a query's lifecycle. It doesn't do that at all yet, but that doesn't mean we haven't thought of that.
Yeah.
On the contrary.
I mean, there's complications, right? If the query has started returning data, for example, and then it fails, are we going to handle that use case and dedupe the data within the gateway? That would be a pretty heavy duty thing for the gateway to do that it doesn't do right now, for example. But it's definitely something that we're all thinking about because of the, it would be a very useful capability to have. And actually, last question there from Nick. Do we support routing to Athena? Athena actually uses a totally different protocol. It doesn't use the Trino protocol, so we do not support Athena as a backend at this time.
But we do support routing to any way or fashion of like a Trino-based data platform that sticks to the Trino platform. So Starburst
right.
Galaxy, Starburst Enterprise, they definitely work. Your own custom Trino fork that you have in your company, and a bunch of other data platforms based on Trino all work with it.